Okay, this is Organic Chemistry, Lesson 4 for Regions Chemistry. Today we're going to learn what functional groups are when talking about organic compounds and how functional groups differ from one another. We're going to learn how to write and name compounds with different functional groups. Today we're only going to focus on the halides and the alcohols, and in subsequent lessons we will address other functional groups. So let's get started. Functional groups are organic compounds that form when one or more of the hydrogens in the hydrocarbon are replaced with either one atom or a group of atoms that give that organic compound now new characteristics and new properties, and therefore it has a different name. We are going to use Table R when we're talking about functional groups. So today I'm going to address halides and alcohols. In our next lesson, so this is going to be lesson 4, which is today. In the next lesson, we're going to talk about ethers, aldehydes, and ketones, which is going to be lesson 5. And then in lesson 6, we'll talk about organic acids, esters, and amines. So let's talk about halides. Halides are referred to as halocarbons, and they're coming from group 17. So we're dealing with fluorine, chlorine, bromine, and iodine. When you look in table R, it tells you that fluorine is called fluoro, chlorine is called chloro, bromine is called bromo, and iodine is called iodo. And that may replace a hydrogen in an alkane. The same rules apply to naming hydrocarbons. The same rules apply to naming halocarbons as we do in hydrocarbons. We give the group, the halogen, the lowest possible number in the chain. So in our first example here, they want us to draw 2-chloropropane. So we have the parent chain is what we start with. Propane tells us prop, 3 carbons. We know it's all single bonds because it ends in ane. We have a chlorine on the number 2 carbon, and this can be either at the top or the bottom because molecules are three-dimensional. And then the rest of our spots are occupied by hydrogen. So this is 2-chloropropane. If I want to write the molecular formula, I have C3. Now normally if this was just propane and it ended in ane, our hydrogens would be double plus 2. So 3 times 2 is 6 plus 2 is 8. But we substituted one of those hydrogens for a chlorine, so it's H7Cl. In the middle diagram, we have two things going on. We have a fluorine and we have a methyl group. So we have to go and name both of those. But let's start with our parent chain. It's prop, and it's all single bonds, so it's going to be a propane. And remember, when you have more than one functional group, you have to name them alphabetically. So fluorine comes before methyl in the alphabet, so this is 2-fluoro, and it is 2-methyl. Should be a comma, sorry, 2-methyl propane. Again, here, the molecular formula would be C. We have 4 C's, 3 in the parent chain, 1 here, C4. H, we have 3 here, 3 here, and 3 here, 9, and then F. All right, 223, trichlorobutane. Well, we know our parent chain is butane, which is going to be 4 carbons. We know that they're all single bonds. Trichloro tells me that there are 3 Cl's. 3 Cl's, and this is their location. I've got one on the 2, I have another one on the 2, and I have one on the 3. The rest of the spots are occupied by hydrogen. Remember to make sure that all carbons each have 4 bonds. Molecular formula would be C4H. Now if this were truly butane, it would be C4H10, double plus 2, but 3 of those spots are occupied by chlorine, so it's going to be H7 Cl3. Let's move on to alcohols. Alcohols are when one or more of the H's are replaced by an OH group. That's the functional group. It's called a hydroxyl group. And when we name an alcohol, we take the parent chain, such as butane, and we drop off the E and we change it to an OL. So butane becomes butanol. And there's your OL ending. We also have to state the location of the OH using the lowest number location. Remember, alcohols are covalent molecules made up of all nonmetals, not bases. Bases are a metal plus OH, as in the example NaOH. And alcohols are all covalent nonmetals with OH. And also, don't get it confused with an organic acid. An organic acid has the functional group ending COOH. You see the OH in there? But this is not an alcohol. This is an organic acid. So in this first one, they want us to draw one propanol. Always use table R as a guide, because the first column in table R tells you the class, so alcohol. The second column shows you the functional group that you should be adding or looking for when you're naming the compound. And very helpful in the last column is always an example. So prop tells us that there's 3 carbons, and the 1 tells us it's on the first carbon, and we're going to number these from right to left in this case because we always want the OH at the end. So this would be 1, 2, 3. And the rest of these spots are occupied by H's. Now, when you look at the example, okay, you can take this apart if you want and draw it so it looks, this is a condensed formula, so you can change it into a structural formula if it's easier for you to look at. And I showed you how to do this by breaking up your C's and then drawing it. So you have CH3 followed by CH2 followed by CH2 followed by OH. Okay. Okay, so in a primary alcohol, the OH is located on the first carbon in the chain. And what that means is when you say primary, it means that the OH is attached to a C, and that C is only attached to one other C. So let me give you an example. We have pentanol. Pent is 5 C's, and you know that the OH is on the first carbon, so we're going to number this way. And then the rest of these are H's. So this is my 1-pentanol. And here, the OH is attached to a C, and that C is only attached to one other C. So that's what makes it primary. The OH is attached to a C, which is only attached to one other C. In a secondary alcohol, the OH is attached to a carbon that is attached to 2 other carbons. So let's look at this. Remember, I talked about this in a previous lesson. These would all be C's. This is just another way of drawing the compound. And I'm going to redraw this for you. So I have 1, 2, 3, 4, 5 C's. So I've got 1, 2, 3, 4, 5. I have OH on the second carbon. So here's my OH. And here the rest of these are all H's. What makes this a secondary alcohol? What makes this as a secondary alcohol is that the OH group is attached to a C, and then that C is attached to 2 other C's, which is different from primary, in which the OH was attached to a C, only attached to one other C. So let's name this 1, 2, 3, 4, 5. So it's pentane, drop the E and add OL, so it's pentanol, and my OH group is on the second carbon, so 2-pentanol. So, knowing what a primary and a secondary alcohol, I'm sure you can imagine what a tertiary alcohol is. A tertiary alcohol is where the OH is attached to a carbon that's attached to 3 other carbons. So let's start with our parent chain. We've got 2 propanol, so we have 3 carbons. We have an OH attached to the second carbon. It can be either on the top or the bottom. And in addition to that, I also have a methyl group on the second carbon, so a CH3. And then the rest of these are H's. So what makes this tertiary is that the OH is attached to a C, and that C is attached to 3 other carbons. So that's alcohols with one OH group that can be classified as either a primary, secondary, or tertiary alcohol. Let's move on to dihydroxy alcohols. Di meaning 2, hydroxy referring to the OH group, so 2 OHs. Example 1,2-ethanediol. Remember, we use prefixes di and tri and even tetra if we have multiple locations of the same group. Here, though, the di comes in the middle of the name, right before the OL ending. So it's ethane, which means 2 C's. The di-ol means 2 OHs. And the 1,2 gives us the location of the OHs. So I've got one on the first carbon, and I've got one on the second carbon. And then the rest of these are H's. So this is 1,2-ethanediol. A trihydroxy alcohol, tri meaning 3 OHs. So propane, and then here's your triol. So this is 1,2,3 propanatrial. The triol tells us 3 OHs. The propane tells us the parent chain is 3 carbons long. And this gives us the location. We have an OH on the first one, an OH on the second one, and an OH on the third one. And the rest of these are H's. 1,2,3 propanatrial. This is also known as glycerol, is a common name for this. Okay, that's it for today's lesson. Tomorrow we will address ethers, aldehydes, and ketones.